kind of thinking about on and off today what it means to have a disciplined mind in science, particularly chemistry, which is my area of expertise. And I guess the first thing that pops to your mind when you think of an overarching principle in science is the scientific method. Everybody's taught the scientific method from probably grade school on now. You do some experiments, you make an hypothesis, and from that you design new experiments to test your hypothesis, and it's either confirmed or denied, and you keep going around and around, and finally that scientific theory pops out. That's all kind of cut and dry, and it seems very nice on paper, but science is a lot more messier than that. If you look at how real science is done, just this cut and dry idea of the scientific method doesn't relate to how scientists think. I mean, it does on a certain level, but I mean, certainly our students have to have a basis of what the scientific method is and how it operates. But at the highest level of doing science, it goes way beyond the scientific method. I mean, a lot of discoveries in science came through leaps of insight. A lot of creativity is involved in science. I mean, if you look at Kuckel, who discovered the structure of the benzene molecule, that popped into his mind one night as a dream. And he woke up the next day and he wrote it down. So there's a bit of non-linear thinking there. There's a bit of creativity. Of course, you could say that it probably wouldn't have popped into his mind if he didn't have a pretty good basis of chemistry to begin with, but it happens in a lot of different cases. You think of Fleming's discovery of penicillin. He wasn't doing research to discover a drug, an antibiotic. It was totally serendipitous. It's something that he got an unexpected result. Mold didn't grow in this little piece of bread, so how do I interpret that? So you have to have, I think, a basic understanding and a basic background of facts in science and how to apply those facts logically to learn new information. But it's not just enough to know the facts. I think there's a lot of creativity involved. And I don't think we talk too much about creativity in science to our students when we teach science. We teach science as a series of facts. I start off in my freshman chemistry course. We talk about different types of matter. What is matter? What is a substance? And what is a solution? And what is a mixture? And it's all pretty cut and dried. And they learn that stuff and they know what it is. But we don't really focus on how to be creative with it. So, on the one level, you have to know the facts, but on another level, it's not enough just to know the facts. And facts are important in science. I mean, you think of science, you think of a factually based subject. However, I think one of the biggest attributes or worldviews of a really good scientist is that they are always skeptics. Even though you have this series of facts, you're always skeptical about not the facts themselves. I mean, facts are facts. If the experiment is done correctly, then the results are a fact. But I think what you're skeptical about is the meaning of those facts. As new information comes to light, the interpretation of those facts can be completely thrown 180 degrees. So you might have certain facts interpreted as a theory, such as Newton's apple falling down, and that became interpreted as his theory of gravity and his universal gravitational equation. And those facts were good up until Einstein came along with relativity, and he found that Newton's law of gravitation was just a subset of a bigger law. So the facts that Newton provided were true, but they weren't true in all specific instances, in all specific cases. So when I think of a worldview as a scientist, I think of someone who has a very healthy regard for factual information, but who also has a large dose of skepticism as to what those facts mean. And it's kind of almost like a dichotomy in a way. You have certain facts, but you're skeptical about exactly what the final meaning of those facts are. And that's different than math, as Sister Jean was saying. When Sister Jean says you prove something in math, you know it, it's true for all time. Well, that's not the case in science. If you prove a theory in science, it's not necessarily true and proved for all time. It can change depending upon whatever information you gather from there on out. Do you want to jump in here, David?
You're doing a great job. I would say that we don't prove anything in science.
We don't prove anything?
In science.
Not in an absolute sense, not in an absolute mathematical sense.
Actually, as I have my students, if they use the word proof in their paper, I'll cross it out to state a suggest. And I think that's the way I approach everything. I don't view much of anything as being absolute. So I would say that I attribute that to my interest or developing into science. I've always viewed things that way. Oh, prepared mind. There's something Steve was saying were resonate very closely with the way I do things too. Just saying them a little bit differently, but I think a lot of science occurs because one is prepared to make that jump. So you had to have a basis. You had to learn. Science is two things for me. Science is a body of knowledge, but science is also a method, a process. And so when we look, one of the discussions that we have here are what should be part of the core curriculum for our students here at Notre Dame College, our undergraduates. And our undergraduates are required to take a science course with a lab. There's debate, should a lab be required with a science course? And if you take science by what it is, science is a body of knowledge, thus the part where you really need to learn that body of knowledge. But it's also that process, and where does the process occur? It occurs in the lab. Now the lab could be a fixed room, it could also be the world itself, it could be outside, it could be in the woods, whatever. So, but anyways, a prepared mind allows a result to be seen. When I was a graduate student in the lab, that I was a graduate student, and they were trying to do an experiment, and it worked this one time, and they couldn't figure out why it worked. Well, the experiment was done in the evening, and our technician would like to work in the evening because he would smoke in the lab. There was no smoking allowed in the building, but at night there was no one around, so he would get away with it. Well, ash fell from his cigarette in the solution that he was making, and what came out of it, leached out of it, was an inhibitor to what we were looking at. And so actually what it came down to was he recognized that was probably the only difference.
So there is a positive benefit to smoking.
That one time. But anyways, he knew enough about the discipline, and he was observant enough about what he was doing in the lab to know that that might have been the significant difference between the experiments that he was doing. And so then you can replicate that and try to see, does that ash cause that? I think another key thing with science is being objective. Scientists, when we design experiments, we try to be objective. Now, of course, we want our theories to be true, but a scientist, a good scientist, is trying to design experiments that will not support their hypothesis. It's easy to design experiments that try to support your hypothesis. But in the end, if you're trying to design experiments that won't support your hypothesis, but your hypothesis keeps coming up, keeps becoming supported, then there's more validity in it. And so when we design experiments, we want to design experiments that somebody else can repeat. And reproducibility, standardization, and reproducibility are key hallmarks to science.
Scientists are human beings too, so they bring all the emotional human baggage to their research. And it's very easy to become biased towards a favorite theory or a favorite outcome in your research. I think you become emotionally connected to it. And it's easy to discard other people's results if they don't conform to yours. I teach actually as part of a coordinating seminar in chemistry for senior chemistry students. We talk about a lot about scientific ethics, and we talk about these sort of things. What's the ethical responsibility of a scientist? And is science a self-correcting field of study? We always think that every published result is true. How do I know if I go and read a journal that that result is true? How do I know that there wasn't some other baggage in there that affected those results? As scientists, we have to be objective and just look at the data.
What were your earliest experiences of science? How did you know that your discipline was going to be science?
Oh, gee, I don't know. I always liked to fool around with things as a kid, even as far back as you know, grade school. I always got, sort of interested in insects, and I got a microscope quite early. Started fooling around looking at things under a microscope, and I just was interested in how things worked. I'd take things apart just to see what was inside of them. Not necessarily being able to put them back together. One thing my mom would not buy me was a chemistry kit, so I guess that's why I ended up as a chemist.
I guess my earliest memory is probably 4th, 5th grade. My dad was a shop teacher, and so I always had a lot of experience doing things with electricity, and so I remember a unit with electricity in 5th grade. And the teacher signaled me out and let me work. I understood the basics so well that she had me working in the back room, and I could do all these other different types of projects. And where the other kids were still learning what made up a circuit. And I think that her confidence in me, or her giving me that freedom, probably stimulated me to continue to look at it. And so I think I've always had an interest in science, but certainly it took off from that point. I would take things apart all the time as well. Things that would be done in the shop. And I remember one specific case, there was a refrigerator motor. My dad, as a shop teacher, didn't make a lot of money, and he had a spare refrigerator motor for it. The thing went out, that he was going to replace it with this. I'll be darned, I might as well take it apart. So I took the thing apart. It was a good motor, but I actually was able to put it back together and it still worked. And so I really didn't get in trouble. but I think that he probably, I think I had a knack for that.
So when you got to high school, what happened then?
I actually said that I would never do chemistry.
Okay.
I remember saying that I had 2 years of chemistry, and it's hard to say. As a teacher now, I know you can't blame a teacher for it, but in some senses, I didn't feel like I got a good background in chemistry at all.
Okay.
And I went off to college saying, there's no way I'm ever going to do chemistry. And by the end of my first year in college, I was a chemistry major.